What's up, guys? Dana Byer. Today I want to cover another example of solving the 4x4 with my 4x4 method, and the goal is to solve the first two blocks, next two centers, LSE wings, CMLL 4A, B, and C. The cool thing is that you're going to see some tricks of non-matching first two blocks. You might also see there's at least swapped centers for the next two centers, and you also hopefully will see the kind of the best part of the method is the ability to recognize parity, odd parity that is, and resolve it. You can also easily resolve the even parity with the 4C extended. So let's go ahead and get this solve started. So I'm going to start with building my first two blocks. Once I transition, I'm going to commit to solving my left block, and then immediately transition to my right block. So we're here. I've already got a good portion of this together. So first two blocks are done immediately. So I see some good opportunities. I see a half bar of orange and red, so I can go either direction with that. And I see that this case is pretty easy with the blue, so I'm going to go blue and orange. Do the M. Notice that these are actually swapped. It really should be red here or green there, but I can resolve that quickly. So next I'm going to solve this pair and then this pair, and then probably be able to solve one of these pairs. So I'm going to go with the L prime U2 L U2, and then R U2 R prime, and then U prime R U2 R prime, giving me three solved pairs. So LSE wings 1, 2, 3 done. It gives me down to my finishing case. So the next thing that I want to do is be able to recognize whether or not there's parity. So at this point I can easily recognize, and I see that I do not have parity, which is great because that just means that I can just transition to here. And so I know that I don't have parity, so I'm not going to spend a lot of time, because you can see that I have four good. I already called it out, and I don't really think that not having parity is really. So now here's kind of an interesting case. I have to still fix my last two centers, but I have actually a T case. So let's go ahead and actually resolve this, and you'll see it there. So now I could have solved it sooner, but I just want you to see the actual shape. I'll go ahead and so rather than looking at it from this perspective, I'm going to actually do my U2 to solve the M slice, and I see that rather than swapping the UF and UB, I'm actually going to swap this 1x1x4 block and this 1x1x4 block, and also swap these centers. So I'm going to go wide U2, slice R2, wide U2, slice L2, U2 only, slice R2. So it's a 6-move algorithm similar to R2, U2, R2, wide U2, R2, slice U2, but instead of doing that, first off I added an L2 in place of one of the R2s, and when I do my algorithm, even if it's just a regular traditional case, I permute the M slice and look at it. Rather than swapping the UF and UB pair, I think of it, I have to swap this 1x1x4 on the UL and the 1x1x4 on the UR. So I go R2, U2, R2, wide U2, R2, wide U2, and it's done. No need to do an awkward slice or do like U2, U2, because I did my U2 setup here. And the other thing is that after 4B, instead of going U and then U2, and doing all these extra moves, I permute my 4A, do my 4A and then my 4B, and I recognize the case and I go U prime or U, rather than permuting the LNR blocks, I solve the M slice. So I go the opposite way, and then I execute the algorithm. So hopefully that helped. I didn't have the odd parity, so we just kind of went straight to it. And we already covered several videos showing how to recognize it. So was able to do it soon and solve the case.